for developer tools at CARTO, and I've been developing geospatial applications for the last 15 years. I'm very excited to be joined today by Emily Schechter, Product Manager at Google. So Emily, if you want to say a few words.
Sure. Hi, and thanks for including me in this demo. I'm Emily Schechter. I'm a product manager on Earth Engine. I've, been at Google for about 9 years and working on Earth Engine just over the past few years. So yeah, today I will be joining for the portion where we show how to export map tiles from Earth Engine to cloud storage and then into the CARTO tool.
Great, thank you, Emily. So in this meetup, we are going to explore different ways to visualize geospatial information using Google Maps and deck.gl. We will see how we can easily create a visualization from data stored in BigQuery using a powerful map-making tool, and how we can customize it further. And Emily, as she said, will show how to prepare Earth Engine datasets for visualization. And finally, we will also have a section to see how we can perform advanced spatial analytics with large-scale datasets. There will be some time for Q&A at the end, but you can add your questions to the chat during the presentation, and we will try to answer them at the end. We are going to record this session, and we will make the recording available after the meeting. So I think I have started recording. So first, I'm going to start with a brief introduction to CARTO. CARTO was founded in 2012 by an environmental scientist and visualization experts, and today we are more than 150 employees. Location intelligence is now more relevant than ever. A huge percent of the data that we collect has a location component, and there is a huge opportunity to use this information to power decisions, both by public agencies and private companies. Our platforms unlocks the power of spatial analysis in the cloud, making it available to new types of users, taking advantage of new data streams, and also helping to solve new use cases. It is a fully cloud-native platform that provides spatial analysis functionality to cloud data warehouses like BigQuery, with functionalities like exploration of your geospatial data sets. You have functionality for creating beautiful maps, for executing powerful spatial analysis functions, accessing to the best spatial data sets, and also to create your own custom apps. Some weeks ago, we were announced as one of the partners supporting Google's sustainability program, and our platform can be used to implement solutions for catastrophe analysis, climate resilience, or biodiversity analysis, among others. CARTO was created to make our world better. Think of how many still dispute climate change, despite scientific consensus. A big part of this is due to the complexity of understanding the data. And we think we can help by putting the best location data in the hands of the change makers. We award grants to a small nonprofit organization with limited resources, working to have an impact on climate change, the environment, the society of the world through data education, advocacy, and activism. We have helped many organizations such as the Red Cross, the United Nations Refugee Agency, or companies like Enveritas that are trying to create sustainable industries like coffee farming. Okay. After this introduction, we are going to start talking about data visualization. So first of all, I'm going to show you the demo that we created for Google Now Cloud Nest that is available at nest.carto.com. In this demo, what we tried to do was to show the potential for electrification of truck fleets in Texas. So as you can see here, we have several visualizations that are really beautiful. This one shows the population. We have camera animation and different effects. We also have all the transmission lines. This is a very big data set that is stored in BigQuery and that we can process using tile sets. And we have also a map with all the different renewable plans, the plans for renewable energy in Texas. And we have an animation here and this Texas boundary. And I'm showing this demo because what we are trying to do today in this meetup is try to reproduce these maps using deck.gl and Google Maps. Everything in this demo has been created with these tools. So I'm going to show you how easily we can do it. So we are going to start by designing a map in our platform. So I'm going to log in into the CARTO platform. And in the CARTO platform, the first thing you do is define connections to your BigQuery data warehouse. I already have defined my connection here. And once you have defined a connection, here you have the data explorer where you can see all the connection. And when you select a connection, in this case, BigQuery, I can see all the BigQuery projects I have access. And for each project, I can see the data sets. I have prepared this Health for Good meetup data set for this meetup. And here we have the data sets, the tables that we are going to use. So for instance, this one is the table with the location of the renewal plans. If I click here, we can see the points representing the location. It's an interactive preview. And we also have a data preview where we can see that for each renewal plan, we have the type, the name, location, geometry, and so on. And directly from here, I can click on this button to create a map in the Builder tool. So when I click in that button, the Builder opens, and here we have the source. By default, we have this representation where all the plants have the same color and the same size and so on. But I can go here and change the layer style. So in this case, I'm going to change the fill color, and I'm going to assign the color based on the type field. This means that a different color is assigned to each one of the plants depending on the value of this field. I'm going to increase also the radius to 30 to make it bigger. And as you can see here, it is very easy to change the color pattern using different color scales and so on. Everything is really fast because everything happens client-side. All the data has been downloaded to the browser, and then we are using vector rendering technology that makes it very easy to change the style, and it's really, really fast. In this case, I'm going to try to reproduce the colors here. So I'm going to create my own custom palette. So I click here. I'm going to have just 4 different colors, and I'm going to add the colors one by one. So I go here. This is the first color, second color, third one, and the final one. Okay, so I confirm, and if you see, we have the same colors that we have here in this demo. You see that we also have like a dark base map. So we can go here and select the base map. I'm going to use one of the Google base maps. This one is a custom style that we have created that we call dark matter. And we have a representation that is quite similar to what we have here. The only thing that we are missing is the polygon with the Texas boundary. And I'm going to add it directly here. I can also add data sources directly in Builder. So I click here and name data from. I'm going to select the data set where I have the boundary that is called this Texas boundary simplified. So if I click on add source, By default, the polygons have a filled style. So I go here, I remove the fill color. I'm going to change this stroke color to yellow, and I'm going to adjust the stroke width. And now we have a map that is quite similar to what we have in the demo. And we are going to start adding the code to trying to reproduce this map using code in our application. So I'm going to use here the Visual Code editor, and I'm going to create a new file. I'm going to start with the Hello World example from the Google Maps JavaScript API. If you see this example in the documentation, it's just here. Here I'm loading the Google Maps API with the API key. And after it is loaded, the init map function is called where we create our map. I have customized the latitude and longitude to the area that we are studying, and we are going to start with Zoom level 6. And I'm going to use the tilt and heading parameters. These are new parameters from the new WebGL features in the Google Maps JavaScript API. And I have also created, I'm using the custom map ID for the dark matter style that I have used in Builder. Okay, so I'm going to save this file, and I'm going to call it Texas Renewal Plans. Okay, if I open now this file, and I haven't made any mistake, we have just our Google base map that is centered in Texas with some kind of camera tilt or camera pitching. Okay, now we are going to add the code to visualize our map, our builder map that we have created here. So the first thing we need to do is to add the script tags for loading the deck.gl application. So you go here to the head section and you add these two script tags. The first one loads deck.gl core, and the second one loads the specific functions for the CARTO module in deck.gl. Then we go to the init map function and we start writing the code. So we are going to select the fetch map function from the CARTO module. And this function expects a parameter called the CARTO map ID that is the ID from the map in Builder. So I'm going back to Builder, I share my map, I make it public. And when I have shared it, I can copy the map ID here from the URL. And I just need to add it here to the code. When the map is retrieved, and this is an asynchronous operation, I'm going to receive an object that contains several properties, including a collection of layers. These are deck.gl layers. And what we are going to do is also to use the Google Maps overlay features. So I'm going to define an overlay, and in this overlay, it's going to be an object type Google Maps overlay, and I need to pass the collection of layers. So what I'm defining here is, okay, I have a deck.gl layer that I want to put as an overlay on top of my base map. Okay, there is something wrong with the syntax here, sorry. And after we have created the overlay, we need to take the overlay. Okay, this is the map, the Google map that you need to use. So if everything is right, and we go back here to our application, now we have loaded the map. You see, it's exactly the same that we have in Builder. We are reproducing the same functionality with the same colors, same boundaries, same property styles, but we have just added 3 lines of code. So this is like a really simple way and a workflow that I think is quite interesting for people working with geospatial applications, because sometimes in your teams, you have someone that is an expert cartographer, an expert creating maps, and then you have someone who is a developer. So this is one way of implementing application with complex maps. So you have the cartographer that use the map making tool to create a beautiful map, and then you have the developer that can take this map and add it to an application, to a custom application really easily. Okay, so we have our map here. Now, the next thing, if you look at this map, you will see that it has a camera rotation. So we are rotating the camera, and it also has some kind of animation here in the points representing the locations of the renewal plans. So we are going to try to add these two effects to improve our visualization, because here we have a really nice visualization where we can tilt, we can remove the header, we can zoom in. As you see, I hope you can see the performance is really good. Everything is using vector tiles, so performance is really, really good. Okay, so we are trying to add this animation that we can see here. And we are going to start adding the animation for the camera, so the camera rotation. I'm going to define here a variable for containing the heading, the camera heading. This camera heading is the parameter that we are going to change. So I'm going to initialize it to 0, and then after the initMap function, I'm going to define another function that is going to take care of the animation. I'm going to call it animate. And here in this function, what I'm going to do is to increase the heading by a certain small amount, in this case 0.01. And I'm going to do the modulo 360 for 360 degrees. And how I can move the camera? It's really simple. With the Google Maps API, there is a function called move camera where we can pass the new parameters. So if we pass just the heading, the remaining parameters are going to stay the same. But here, what we are doing is changing this heading. Also, in some other libraries, it's called the bearing parameter. Okay, and what we need to do, we need to tell the browser to perform the animation, and we are going to do that through the window request animation frame function that expects the name of the functions that you are going to use for animation. And in addition to calling it for the first time here, every time we do a frame, we are going to call it again. So let's see if this works. Okay, you have now the same visualization, but if you look at it, we are moving the heading just a bit every time we are creating a new frame. So creating this kind of effect is also really easy, working with deck.gl and with Google Maps. Okay, and then we are going to try to do the second effect. If you see here, what we have for each location is like a circle with a fixed radius, and that has like a darker color, and then we have another circle with a brighter color, and where the radius is changing. It's changing from 0 to the whole radius. So we are going to try to reproduce this effect as well. So for that, we are going to define another variable that we are going to call the current time, and it's going to start also with the value 0. And what we are going to do in each animation step is to increase this current time variable. Okay, it's really easy. I'm going just to put 1. And then we need to add the code for doing the effect. How we are going to do that? We are going to clone the layers. So we have here two layers, the one with the Texas boundary and the one with the circles. And what we are going to do here is to clone the layers in each step. Cloning is something that is really cheap when using deck.gl, because deck.gl computes the state from the previous state. So if the layers haven't changed, it's computationally very cheap to do the cloning of the layers. But to be able to set the overlay again here, instead of having a local variable, I'm going to define the overlay also as a global variable. And I'm going to store the layers in a new variable that I'm going to call the map layers. So the layers from the CARTO map. So here I will get the layers, and then here we can add the layers of the map layer. This is the same. Okay, so now we need to be sure that we have the overlay already initialized and our map layers are also ready. And if that's the case, we are going to create a new array of layers. And if this new array, what we are going to do is for the first layer, and this is the Texas boundary simplified layer, I think. If not, we will need to change this later. We are going just to clone it. And for the second layer, that is the layer with the renewal plans, first, we are going to clone it, but we are going to change the opacity parameter. So it appears as darker. And then we are going to clone it again. So the same layer. So we have two different circles for each location. And in this case, what we are going to change is the point radius scale. This is one of the styling properties that we can use to change the size of the radius. So I'm going to take 0.2 and using a sinus function, I'm going to change the radius scale. Okay. And if everything is good, let me see if the index are correct. No, I don't think so. Maybe it's the other way. Okay. Yes. Okay, I know what's happening. Sorry for that. I forget to update the overlay. So after you have created the new collection of layers, you need to call the overlay and you need to update the layers property. Okay. So to the new layers that we have created here. Let me get this back to the old indices. Maybe it's the other way. Sorry, I need to inspect the code to be sure. Okay, animation current time. That is a typo here. No, I have another typo, sorry. Okay, current time. Okay, finally we got the effect. Sorry, but I'm trying to do this live coding. It's difficult. So if you see here, now we have both rotations, both the camera rotation and also the animation here. So you see how we are replicating the effect by cloning the layers. And creating 2 layers for the Texas renewal plants. So you can see here some kind of effects when the circles are overlapping. This is something that is happening because we are rendering in 3D, and sometimes we have this effect that is called seeds fighting, where we have a problem with the depth buffer. So the buffer where we are storing the seed coordinate for each one of the layers that we have. I'm going to show you how we can work with advanced parameters in the deck.gl visualization. So we have this parameter that is controlling if we are doing depth testing or not. We can just create it here, and then we can just add it to each of the layers that we are creating. So we just need to add the parameters here for each one of the layers. Let's see if the effect now is removed. So if you look here, even if the circles are overlapping, we don't see this kind of flickering that we were seeing in the first way. So this is the customization of the visualization. And you see a really slightly complex visualization that we had here that could be difficult to replicate. We have just designed our mapping builder, obviously without the effects, and then with just a few lines of code, everything that you can see here, so this is probably something like 20 lines of code, we are able to replicate this visualization where we are doing complex styling based on a type. We are getting data directly from BigQuery, and at the same time, we are doing a camera animation and we are doing a feature animation on the locations. Okay, so this is like the first step of this meetup. Now I'm going to pass the turn to Emily, who is going to show us how you can prepare Earth Engine datasets for visualization. So please, Emily.
Great, thank you. So for those of you who joined after I introduced myself, I'm Emily and I'm a product manager on Earth Engine. And I'm going to demonstrate how you can export map tiles from Earth Engine to Google Cloud Storage. And in Earth Engine, what this means is you use the export.map.toCloud storage, which is exporting map tiles that work with the Google Maps API, and they also work with Google Earth. So I will start by presenting my tab of the code editor. Can you see this? Yep. Yes, okay. I'll show you a bit more of the code. I am showing a script that I wrote before. I'm not so brave as to try and do it live, but I will kind of go through what I did and tell you about each of the steps. So let's see. The first thing is that I need a data set. And I'm going to grab some data from analysis from the Earth Engine data catalog. And let's say I want to sort of stick with the Texas visualization that we were just showing. And in particular, I want to visualize a climate projection for Texas, maybe into the future out to the year 2030. So if I search for climate projection, you can see that we have these NASA NEX data sets. And let's say I pick this one that I'll use. And so here you can see kind of the data set description, which describes the data set, its downscaled climate scenarios for the United States. You can see on the left-hand side that this is the collection snippet for how you import it into Earth Engine. And if you click the C example, it will open this data set in Earth Engine. And in particular, I'll also show you that in this bands tab, you can see the different bands in this image collection. And I've decided that I'm going to use this band, the TAS min, which is the monthly mean of the daily minimum near surface air temperature in Kelvin. So I've imported this into the code editor. And what I'm doing is I'm going to filter it just to the month of July in the year 2030, because that's sort of the date range that I'm interested in. And then I'm selecting that band that we talked about, which is that daily minimum air temperature. I'm calling it minimum air temperature. Then I'm going to use this median function to reduce the image collection to a median image. The next piece here is I'm creating some visualization parameters to figure out when I visualize this image collection, where I want to set the maximum and the minimum. And one way that you can kind of get started by figuring out what to set those is in the bands you can see here, this is the minimum and this is the maximum. So I can use those to sort of give me an idea of what I want those parameters to be. And then I'm using this visualize function, which converts it to an 8-bit RGB image. Then here, I'm setting the center of the map to Texas, and then I'm going ahead and I'm going to add the layer to the map. So let me just run that, and I'll remove this one because we haven't done that yet. You can see here, this layer that's coming up is this climate projection layer that I just created. So then the next thing that I've done here is I actually defined an export region by drawing a polygon around Texas. And I also visualized that on the map, which you can see here. It's this, this rectangle here that I drew around Texas, because I know when I want to export this to cloud storage, I'm actually only interested in this sort of area around Texas. And then finally, I'm using the export.map.toCloudStorage function, describing just my median image. I'm putting in here the description of this export that I want to do. This is the name of my cloud storage bucket that I already created. This is the max zoom level, and this is the export region. So when I click run, what it actually does is it brings up this task over here in my task panel called map to GCS example, which is what I called it in this description. And when I run it, it will open this export dialog. And one of the things you can do in here is put in your Maps API key. So if you click this button, you can use that to generate a Maps API key. And I had already generated a key before this demo. I pasted it in here. I pasted in my GCS bucket name, which I had already created. And this is the same name that I had given it in my export function. And then this is what I'm calling it, is my maps to GCS example. Okay. So I'm not going to press run because the last time I did this, it took about 7 minutes. But I can tell you that when you do this, it will basically export the XYZ sort of pyramid images to my cloud storage bucket. And one other thing that I just wanted to demonstrate is that there's also this function down here called ee.data.getMapID. And what that does is it will generate also a map URL, but it is a short-lived URL. So it only actually lasts for a couple of hours, but it is more dynamic. So when I run this, what you can see in my console is that it's actually giving me the URL right here. So when I'm using the CARTO Builder tool, I can either use this URL, but it's dynamic, but it's more short-lived, or I can use my URL that's coming out of my GCS bucket. I think that's it. So I will pass it back over to Borja.
Okay, thank you, Emily. And now I'm going to show how we can take these tiles, these raster tiles, that we have generated from Earth Engine and visualized in a deck.gl application with Google Maps. So I'm going to add a new page here that I'm going to call climate. I'm going to start the same with the Hello World example from the Maps API. And the next thing I'm going to do is to add the script tag for deck.gl. In this case, I'm going to use just pure deck.gl code. So after we need the map, we need to add, it's the same. We need to add the deck.gl layer. We are going to create an overlay with this layer, and we are going to set the map. I'm going to copy the code to ensure that we have time for the last section. So if you see here, what we are creating is a deck.gl layer that is called the tile layer. And in this tile layer, the first thing we need to pass in the data parameter is the URL to the bucket, to the Google Cloud Storage bucket, where we are holding the raster tiles. These raster tiles have been created for a zoom between 0 and 6. They have the default width and height that is 256. And then we need to render that. So we are going to use this render suppliers property. The first thing we do is to get the bounding box for the tile. And after that, we create a bitmap layer that is going to take the PNG file from the raster tile and draw the PNG in these particular locations. And after that, it's the same. We already have our layers ready. So what we need to do is to create the overlay and to set the map. So copying from what we have first, it's the same. We have our layers array, then we create the Google Maps overlay, and then we set the map for the overlay. It's always the same when you are working with Google Maps and deck.gl. So I'm going to open, let me go back here. And we have exactly the same raster tile set that Emily was showing with Earth Engine. This is in 3D, so it's working really fast. I don't know if you can see it, but the performance is really good. And another interesting thing for Google Maps with deck.gl is that deck.gl and Google Maps use the same canvas, the same WebGL canvas. We are using WebGL for rendering, and we are using the deck.gl canvas. So in this case, we can do things like having the layers on top of the deck.gl layer. That is not an easy feature. That, for instance, if you are using other base libraries with deck.gl, like Mapbox, this is a feature that you cannot implement because Mapbox and Deck are drawing in different layers. But with deck.gl, the performance is better because everything is rendered in the same layer. So as you can see, it is really, really easy to work with this. And then I'm going to go to the final section. In the final section, I want to show you a bit how you can perform advanced spatial analysis on using BigQuery and the CARTO platform. And I'm going to illustrate this analysis with a map. What I'm going to do is to try to visualize the distance from the population to the nearest alternative fuel stations. So I have downloaded a data set with the alternative fuel stations for Texas. And I'm going to start by adding it to the map. Instead of adding the table directly, there is another option, is that I can type my own query. And just for the sake of showing you how to work, I'm going to use that. So I can select just the geometry field. I don't want to get anything else. And then I need to put the path to the table that you know in BigQuery is formed by the BigQuery project, then the data set, and finally the name of the, sorry, Texas Alternative Fuel Station. This is the name of the table. So then when I click run, what I'm doing is sending this query to BigQuery. It's being executed in BigQuery, and then it is returning the results to the browser. In this case, it is returning the results as GeoJSON. So I have everything ready here. This is the locations for the alternative fuel stations. These are mainly stations for charging electrical vehicles. And as you can see, they are usually clustered around the main cities, in this case, in Texas. I want to calculate the distance from the population. So what I'm going to do is to also add the table with the population data. One important thing is that this table for population has been already transformed to H3. I don't know if you are familiar with H3, but H3 is a spatial indexing system where you have the Earth surface divided into hexagons of different resolutions. In this case, I think the hexagons are using resolution 6. So what I'm doing here is to represent the hexagons. And if you see, for each hexagon, we have two different columns. The first one is the H3 index that identifies uniquely the hexagon. And then we have another column that is the pop, representing the population, the number of people living in this hexagon. So I'm going to go here to the layer style, and instead of using the same color for all of them, I'm going to draw it based on the population. So if you see here, we can apply a different scale here, and we can see clear where we have the most population. So here, for instance, you have this population of 86 inhabitants. So we can do also other interesting things like extruding the polygons based on this value. So imagine I take the same column, that is the population, and I switch to a 3D view. You will see that we have different values depending on this population with a different height. But in this case, I'm going to keep everything 2D just to understand better the map. So now we have two different sets here for the layer representing, for the layer representing the alternative fuel stations. I'm going to select a different colors so we can visualize easily where we have those layers. In this case, I'm going to change to a brown. I can easily reorder the layers here. So we draw the alternative fuel stations on top of the population hexagons. And why am I using H3? I'm using H3 because there are complex spatial operations like spatial joins or spatial intersections that are computationally expensive, but if you use like a common geographic support system like H3, they become easy joins, easy regular SQL joins. And I'm going to show you here how we can use that to our advantage. So I'm going to add a new custom query, and I'm going to use some of the functions in our analytics toolbox for BigQuery. So here I'm using a function from the H3 module that is the k-ring distances. And this function, what it's doing is calculating all the hexagons around another hexagons. So I'm taking the alternative fuel stations, and around the alternative fuel station, I'm calculating all the hexagons that are in the vicinity. And I'm ordering all the hexagons based on the minimum distance. So what I have here is for each hexagon in this visualization, I have the alternative fuel station that is nearest this hexagon. And then I'm joining to the Texas population dataset. So instead of doing a spatial intersection that it's going to be really expensive in terms of computation, we just need to do, in this case, a left join. And we join using the H3 index. That is a really fast operation. So here, in addition to just adding a table to be visualized, we can also execute a complex spatial analysis function and then add the result to the map. So if I click run, this is going to do this calculation, and we are going to have a new layer that is going to represent the distance from the population to every alternative fuel station. So here I can see to match, but if I move it below and then I change the style, so we represented this based on the distance, we have a really nice visualization that is also really fast, where we can see in darker color, so those the population that is near, really near an alternative fuel station, and those regions in yellow are those regions that are farther from a electric vehicle charging station. So this is, in this case, this is also interesting for the potential of electrification. It can help us to understand where we should invest and where we have enough stations available for the population. This is just an example of a complex spatial analysis that you can do really easily just using a SQL statement. So this was the last practical example, and then we can have some time for Q&A. I think that you have added some questions to the chat, so we will try to answer them now. Okay. So let me start from the beginning. I have there's a question from Matt Gregory indicating that the CARTO map ID layers, asking if they include the base map information. The information is included, but it's the information from the base map for CARTO. So if I select here a base map from CARTO, the information is included. But in the case of Google Maps, you already have to initialize the base map with the Google Map ID, and this is something that you can do, and it's included. I didn't show that, but if you go here, this object that is returned is not only a collection of layers, but there is also another property that is called map style, and in this map style property, you have the base map that you are using in your map. So it's also included. Another question from Norman Avila. Okay, that I think that Matt Gregory already answered. So request animation frame is an standard web API function. You don't control the timeout. The argument, as Matt Gregory has answered, is the function that you want to animate. So it depends on the workload, the current workload for your computer. The request animation frame will be called more frequently or not, depending if you have a lot of tasks already doing. Okay, Emily has shared the script. Anil asked about the recording. I told it at the beginning. So we are recording the session, and we will share it with you after the meeting. So the session and also the source code that we have written. Okay. Now, Norman Avila is talking about the advantage regarding Google Maps, regarding the tile layer. So it's not really an advantage over Google Maps. It's right that you can use tile layer. And in this case, is just an example of how you can mix this type of information. Usually you are going to use this raster tile from the Earth Engine dataset in addition to other deck.gl layers. So it's not that showing a particular raster tile set is something that you can do only with deck.gl, but if you want to mix it, it's going to be better to do it. So you were right, Norman. Okay. Well, it seems that there are no more questions. If anyone can ask anything. Okay, so what's the main purpose of deck.gl is creating advanced visualizations. So usually in mapping libraries like Google Maps or Mapbox, the kind of things that you can do when visualizing geospatial layers are quite limited. So you can change colors, these type of things. But if you look at the deck.gl documentation, you have a big catalog of layers, probably around 40 layers with different ways for representing the information. So you can have things like arc layers, you can have different types of clustering and aggregation. You can work with 3D objects using a scene graph layer, and the options are really extensive. So I mean, if you are going to go for a simple visualization, probably with a standard mapping library, it's okay. But if you want to create an advanced visualization and you need really good performance, deck.gl is probably a very good option. Okay, so yes, we have a repository with more examples of visualization with deck.gl, and we will share it with you in the mail we will send after the meeting. Okay, so I don't know if there are more questions. Since there aren't. So thank you very much for attending this workshop. I hope you have learned some useful tricks for doing visualizations. And we will get back to you with the email, sharing the recording and sharing the source code that Emily and myself have shown. So thank you again for taking the time. Bye-bye.